The number of jobs for electrical engineers and computer scientists has exploded over the last half-century. Just look around. In electric power, communication devices, medical instruments, aircraft and spacecraft, intelligent highways, and computers. But no matter which discipline or specialty engineers are involved in, certain core functions, such as research, design, testing, and evaluation, manufacturing and applications, and maintenance and service remain constant. Research is the beginning. It starts with an idea or a need. Theories are formulated, tested, and prototyped. Careers in research can be found at universities, national laboratories, as well as private institutions and corporations.
It amazes me at times that virtually everyone that I work with has a passion for automobiles. We call each other a bunch of gearheads. So, we can get together and talk about work in one conversation, and the next we'll be talking about our personal vehicles, and the conversations aren't really that different. I'm an electrical engineer, I guess, in a field that would have historically been considered largely a domain of mechanical engineers. So I do design work for the electronic systems that control automobiles. We're talking about everything from fuel injection and ignition systems to anti-lock brakes and climate control and radios, etc. A typical day I'll come in and do some electronic design work, and everything from drawing schematics to generating printed circuit boards in a prototyping environment. I instruct technicians on how to assemble the boards, and then finally we'll get down in the lab and drive current through an injector and look at waveforms on needle lift and gas flow rates, and so I'm involved from the very beginning with every step of this development process. I'm doing some design work for a fuel injector driver on a locomotive engine. These fuel injectors are designed to flow natural gas, and I built a current tracking amplifier that will pump as much as 30 amps of current at 100 volts through these injectors in an attempt to open a solenoid very quickly and then hold it open for a specified amount of time. The Institute is a research for hire organization. We do no production type work. So a company will come to the Institute and will be interested in having a particular problem addressed or having a particular solution generated. And the Institute, for instance, with this natural gas injector, will generate answers to problems, and then will in turn hand those answers over to industry so that they can be productionized and put into actual use. The division of the Institute that I work in, if you were to take a look at the makeup of the engineering staff, it would be a microcosm of the automotive industry in general. We have about 40 mechanical engineers on staff and about 6 electrical engineers. So what we have is a large contingent of mechanical engineers and a growing number of electrical engineers becoming involved in every aspect of automotive design and production and control. I interface with clients. I take them on tours of the facility. I attempt to sell my ideas to them. I write proposals, and I manage projects. And it's not something that is my favorite part, but it's certainly something that goes hand in hand with the rest of the jobs.
Kathleen Krish works at Lucent Silicon Research Laboratory. She stresses the importance of graduate studies for the work she does.
In terms of doing R&D, I think there's absolutely no question that in my field, integrated circuits and silicon technology, you do need a PhD. It's a huge field. It's really growing a lot, but you need a PhD to do R&D. The silicon field is really a neat field. I think part of why I like it is because it's so hard to pin down. Because there's the people that I work with are from every discipline. We have physicists, we have chemists, we have chemical engineers, electrical engineers, material scientists, and this is the formal training that each person had. But we all just overlap, and you really need to know a little bit about all of these fields to work in silicon technology, because so much needs to come together to make it work. This is an environment where we're trying to be the ones pushing things to go faster, and so hopefully we're taking some part in that, and so we know what's going on. But that's impossible to really always know everything. And so you try to read journals. It's very hard to keep up, but at least skim through those. Go to conferences. Go listen to talks that aren't just the ones in your field that you feel comfortable listening to, but actually try to broaden your horizons. And then just talk to people and ask people what they're doing, and try to learn about what's new.
Design and development of products apply the fruits of research to practical problems.
The aerospace industry does go up and down. It's cyclical, and I was hired in right near, it basically had bottomed out, and it was just barely starting to swing back up again, and everyone still had a lot of negative memories, and the morale was pretty low in general when I hired on. But the company had finally realized that things were going to turn around. It was time for another upswing, and they were just starting to hire a few people, and I was one of the first of those. And it was really interesting coming into the company and having a lot of people still pretty gun shy. They could remember 6 months or a year back when people they'd known were being laid off, and everyone was telling the horror stories. And it was pretty strange coming in and being all enthusiastic and hearing this kind of darker side. Okay, I mean I've always really loved the space industry. I've always grew up watching the satellite downlinks from NASA. And seeing the pictures of the space shuttle and the astronauts, and my father was really enthusiastic about it, so it sort of caught in me all throughout my life. There's a real effort to design one set of electronics or a few sets of electronics and use them over and over again every place to save money and time, and I work a lot on defining those architectures, the way what functions go in which boxes, as we call them. What are the electronics going to do? What do they need to do for certain missions versus other missions? How do we trace that back to the requirements of some program? So when I come in the morning, there's usually already a whole collection of voicemail messages and emails built up on my computer, and I just start going right down and you work through the urgent messages that people have come up with over the night and sent you, and usually I have a couple hours of meetings each day. I usually have telephone conferences with subcontractors and companies that are developing electronics for us that I spend a fair amount of time dealing with. I also spend a good amount of time doing reviews of the detailed designs. I'll go to design reviews where the board designers or ASIC designers are talking about how they've implemented some function that's supposed to meet requirements at a spacecraft level or a subsystem level. And I'll go there with supposedly a good understanding of what the requirements are and go step through their design with them, and that's where my electrical engineering background lets me understand what they're talking about.
I was hired here as a senior design engineer, and I am working on the instrument side of this company, which is the instrument that biologists around the world will be using to do cell manipulation. You've heard recently of a cloning. Well, that cloning was made using instruments similar to the one that I'm designing and maintaining. Again, in a small corporation, you have to wear several hats. I am involved with the sustaining side of the house, which is keeping product that are produced currently in good shape. If there's a change in component or if something varies from its design goal, then I have to bring it back. I'm also in charge of the documentation, basically how to build the instrument, how to test it, and how to service it. I'm also in charge of finding replacement parts for those that become unavailable. And I'm also in charge of the training of the technicians.
How can you tell if a product will work the way it's supposed to, that it will be user-friendly? That's the job of the test and evaluation engineers.
I want people to have a good experience using my products. and I find that I'm good at breaking things from the developers and finding out what's wrong. Well, I got into quality assurance because I first started out when I was in school working as a part-time programmer, and then from programming I started working on databases, and the various different jobs I held required skills in multiple computer systems, IBM PCs, Macintoshes, Unix. I got a great big skill set that was quite wide but not really very deep. And then when a job opportunity came here in San Diego at another company for testing software, my skill set was pretty much ideal. That job folded into, or expanded into really, quality assurance department for that company. And I found that testing software and making sure that software and the components involved with it worked best for the customer was what I really was good at. In writing a validation test program or a test plan, I try and think of all these situations that might occur or things that might break the program. I talk to the various development engineers as to what they think might be an issue. I talk to the marketing people and what they think might be the program might be used for, and try and put all these different things into various different test cases that will exercise the program. And then I run through it and find the ones that break and tell people about it, and then wait for the new version and test it again and break it some more and test it again until it's ready to ship. I think it's mostly, one thing that drives me the most is challenge. I like to work on something that's teaching me new things and that I can be a good contributor on, and also that I'm building something or I'm working on a project that people are going to use and like. If I could be making twice as much on something that I wasn't interested in, and that wouldn't be a good job.
While not everyone specializes in testing and evaluation, it is an important part of many jobs. After serving in the Navy as a nuclear electronics technician, Arnold Motley went for his EE and landed a job at IBM as a systems engineer. His job includes testing and evaluation.
So I come in the morning, check my email, check my phone messages, come out to the lab, and start right away on what I finished up the day before. And usually sit here till lunchtime, back and forth to my desk a couple times, and usually end up in the lab, leave about 5 o'clock and go home. Well, right now we've just received our new planer board in, so I'd say the first 60% of the design cycle is spent in the lab, and I'd say 80% of the day is in the lab, debugging, redesigning, testing, and then later on in the program, near the end, more time is spent out in the office generating reports, charts, performance data, that sort of thing. I think in this business, once you're done with the board and you finish the project, you usually have to do a presentation and stand up in front of at least 20 to 40 people, generate a presentation on the board, how it performs, how it functions, and how close it came to your expectations. And on a weekly basis, we have to generate or go to a meeting and give an update to the rest of our group on how our particular department is doing. You have to work well with other people, many other people. I probably deal on average with 30 people a day, different people a day. And so you have to have your communication skills up to par. Your analyzing skills have to be there as well. Being able to debug a board really helps. Given a board that doesn't work, you don't know anything about it, you have to sit down, generate a plan of attack, and then attack the board and find out what the problem is.
Once the product is developed, it goes to manufacturing, where it is produced in large quantities. Manufacturing technology has become an important focus in recent years as global economic competition has forced companies to reevaluate basic manufacturing techniques. To increase productivity, companies have turned to robotics, statistical process control, just-in-time parts supply, and other innovations.
And so what my group is responsible for is procuring generators, contactors, control units that control the system that creates 115 volt AC power on an airplane, which is the main source of electrical power on an airplane. A typical day depends on where we're at on a given program. Right now we're working on designing a new system, and we're right at the front of that, and so we come in and we go through a lot of meetings actually to find out what our requirements are this time around. What's the environment going to be? Are we going to have any new requirements? And right now we're working on a specification. There's 6 of us that are actually working on that, and we actually spend 2 hours a day just reviewing what each other has done before we put it in the spec. Later on, when the supplier comes on board, we'll be working a lot with them. We'll be going over what our requirements are, what they can do, because the supplier actually creates the hardware that we buy for the system. After that, we'll go into a testing phase, and there will be testing here at Boeing and testing at the supplier. I worked on the 777, the 777 airplane for 3 years, and the day they ran the engines for the first time, and I got to be on the flight deck to watch to see if my generators came online. And they did. I mean, that was neat. That was probably the most exciting thing. The second one was the day it flew, and we all walked out and watched it take off. And when we heard it was going to go land, we all ran out and watched it land again. Yeah, that's fun to see.
You may be interested in or dubious about management as a career goal, but statistics show that it remains a major career destination for engineers.
Okay, I'm what's known as a section manager for Tandem Computers. It's a business role with a technical edge. And the technical edge is that I hire teams of engineers to work for me. And they're extremely technical. And I need to understand the details of what they work on clearly enough to abstract it to the 30,000-foot ceiling where executives live. Executives are interested in market, channels to market, budgets, cost of ownership, a lot of things associated with products. The engineers are interested in the interesting way to build the functionality that you want, whether it's software or hardware. So that's my role. I play a bridge role. I manage the process that people are working in and try to facilitate teams, the schedule that people are working within, and then I do what I call provisioning. Things like this lab. This lab is paid for by Tandem Computers. Someone had to go and ask for and prove the need for the equipment in this lab. So I did that. So let me talk about what happened to me in my adult education. About 1988, I had been in the industry for 10 years. The half-life of your skills is, say, 5 years. If you give it what you learned in school, so you assume what you learned in school is half as valuable in 5 years, half again as valuable in 5 years. And so you have to find a way to re-educate yourself continually. What I did for myself was I took a job working in a division at Tandem where the goal of the division was to re-educate people. Of course, as the first step, I had to re-educate myself and had to go out and take courseware, find books to have the time to read the books, present the information back because we were doing it for a reason, and then use those skills in place for a while in order to pay back for the privilege of getting to go do that. I did that for 8 years because I was pretty good at it and ran projects there. Now I'm back out of that and I'm back into a product division again, working on product. Putting all those skills to work. In about 6 years, I'm going to have to go and re-educate myself again, I'm sure, unless I can manage to do continuing education while I work. And when you're in a product job, the time to market issues are so important that you pretty much just focus, you narrow your focus to delivering every product that you're managing, and you don't really look outside of that. So pretty much you have to find a way to continually re-educate yourself.
I work more on working with the business unit, identifying at a high level what they want. Typically a marketing guy will say, well, we want this feature. And then I go to the technical people and say, well, can you do this feature? and then they have to go figure out the technical things. And then once they come back and say, well, we can do it, then I have to work through the hoops of how we put that into production, how we get the software and the hardware and get it into the supplier and make all the things happen so that we can deliver it to the business unit. So it's not the technical sort of things that I learned in, microprocessors class or softwares classes back in college. The way I would describe travel is anybody who says they love to travel hasn't traveled enough for work. Business travel for me, I went to South Africa. I flew in on a Saturday, recovered from jet lag on Sunday, and then drove all over the country Monday, Tuesday, Wednesday, Thursday, Friday, and saw the country go by at 100 miles an hour and visited the suppliers and people we needed to and did work all the time. Hopped on a plane Saturday and flew back. And then just recently, similar thing, I was in Sweden, and you fly in and you're working, you're very busy, and there's very little time to do enjoyment. If you have time to enjoy something, then there's something wrong.
Graduating engineers rarely leave college and start their careers as consultants. Traditionally, consultants work in the industry for a while, gaining a strong network in some niche of engineering. Using this experience, they start their own consulting service.
My consulting and contracting business got started as a sideline of things I did on the evenings and on weekends while I was working full-time. And it grew, and as my reputation grew as someone who could come in and handle things and, fix send mail or install a new disk and, do various types of system administration tasks, I'd get more and more requests for that. And the business just slowly grew until a point where one of my customers, one of my part-time customers said, well, we really want you to come to work for us full-time for 6 months. We've got a particular network reorganization that we want you to do. And I thought about it, and I actually decided I didn't want to do it. And but I didn't want to tell them no, because I was working 8 or 10 hours a week for them, and I wanted to keep doing that. So I figured, well, I'll just quote them an hourly rate that they won't agree to, because they weren't going to pay my 8-hour rate for 40 hours a week. They didn't even blink. They said, okay, when can you start? And I was like, oh, right. Now I got to figure out whether I'm actually going to do this or not. And I thought about it for a couple days and decided, okay, I've got enough of this sideline business. I've got enough people coming to me that I'm having to say no to because I don't have time, that I think I can make a full-time going of this. So for me, it wasn't any, well, I'm going to quit my job today and be a consultant tomorrow. It was, I'm going to build the consulting business and the contracting business on the side until it reaches a level that I think can sustain itself, and then I'm going to leave my full-time regular employee's position. If you're going to be a successful consultant or contractor, you've got to be able to deal with uncertainty. Okay? You've got a job today. You may not have something lined up for next week or next month. The way you deal with that is by charging enough when you are working that you can ride out those periods when you're not working. But if you're going to get completely stressed out because you don't know where your next paycheck is coming from, if you don't have the financial discipline to save the money when it is coming in so that you'll have some to spend when it's not coming in, then consulting or contracting is not going to work out well for you.
A company's concern for the product doesn't stop with the sale. Most companies, particularly those that have complex products, have support divisions staffed with application engineers to help customers apply their products, as well as to solve problems that may arise.
The most challenging part of my job is being able to respond to different situations at all times during the day. You never know what new problem is going to surface during a day of applications engineering where you're actually helping the customer solve their application. It could be anything from one phone call to the next. Because we have to talk one-on-one with the customer, I've picked up phone calls where a customer was so angry and so upset that he would start yelling at you over the phone. he may not understand that you're a fellow engineer who is trying to help him with the situation. And basically, I just stay calm. I try to find out what the problem is. And eventually, perhaps what we need to do is have an email communication so that we can describe the problem in a clear, concrete terms, which we've done before, or conference call with a so-called developer in order for him to feel like he's talking to someone who knows what the root of the problem is and who can help him solve it, which we've done also before. It doesn't really do much more than talking to you directly, for example, but it helps the customer feel better, and that's really what we're aiming for. Our work schedule here at National Instruments is pretty busy. We get here relatively early in the morning, around 8 o'clock or so, and we stay here until about 6:30 or 7 in the evenings. Sometimes we'll take lunch, sometimes not, and sometimes we will take work home with us on the weekends. However, the culture here is such that you enjoy doing what you do with your fellow coworkers, and it's not so much schedule oriented as are you getting your projects done. And if that's the case, then your schedule is as you make it. Because the company is so dynamic, and because our industry is so dynamic, there are many, many different career paths that you can choose as an electrical engineer. One of the things that I've discovered that I really enjoy is software marketing here at National Instruments, because it is not a normal business-oriented marketing position. It's strategic marketing. You are defining where the products go in the future, where our technology will expand in the future. So you have to be an engineer in order to do this, in order to understand the technology and figure out where best our next niche is going to be. So as far as my career paths at this point, I could have gone into research and development. I could have gone into sales engineering, where you would go out and actually go to a customer site and help them solve problems. But I chose to go to strategic marketing, which is just another area in which electrical engineers can work.
Well, there you have it. A brief look at what's out there. But there's much, much more in the field of electrical engineering and computer science. A person with the appropriate technical background and skills can find work almost anywhere, in small, medium, and large companies, in traditional areas such as aerospace, defense, research, telecommunications, transportation, manufacturing, software, and hardware, in unexpected areas like banking, entertainment, medicine, environment, and law, in the private sector, government, and education. A video like this can present only the tip of the iceberg. Get out there, look around, see what suits you. The opportunities are vast. The opportunities are waiting.